All right, hello everyone. So today we're looking at the following question. Define the function g whose domain is the integers to its codomain, the integers, as g of x equals x cubed. So you take an integer and you cube it, and that's the result that you have in the codomain. And in the question here is this function g onto. So let me start off talking about really quick when you have the domain being the real numbers. If the domain is the real numbers, the answer would be yes. Okay, and this has to do with the fact, well, one of the facts that the function of x cubed looks like this, and it basically takes on all range values. Okay, and then I'll get into what onto means in a second here, the formal definition. But I just wanted to refresh ourselves on what some people might have seen in maybe an algebra calculus class, that this function is onto, and it's 1-to-1 as well, with the real numbers. However, that is not always the case when you change the domain and the codomain here. All right, so how does that work for us in terms of onto and the definition? And for here, a function, well, any time really, but especially in discrete math, the definitions are really important. A function going from domain A to codomain B is onto or surjective if and only if for every element W and B, there exists an element X and A such that f of x equals W. So in our case, imagine your function going between these two circles. This circle is Z and this other circle is Z. This is the domain, and this is the codomain, and yeah, your function g, takes one element here and it sends it over there. And a function is onto if you pick anything over here in the codomain, it doesn't matter what it is, there exists an element in your function, in your domain, for which the function takes that element and sends it to the one that you picked in the codomain. Okay, so the answer to this would be no. Okay, if you let w equals 2, you're just using the notation. Okay, 2 is an integer. Well, is there an integer that you cube that gives you 2? That's what you're looking for when you're trying to show something's onto, is that there's some element for which the function operates on, for which when the operation gives you, well, any number. And yeah, and I picked 2. So if this function's onto, there's got to be an integer for which you cube equals 2, but there isn't. The answer here is no. No integer. Solution. Okay, many people will say, well, I'll take the cube root of 2. Yeah, the cube root of 2 would work if I was talking about the real numbers here. Cube root of 2 is a real number, but it's not an integer, so there's no solution. Now, there is a more formal way of proving that there's a no solution. Well, I'm just saying it, and in so many words, yeah, we can think of, like, can you think of any integer whose cube is 2? No, but formally speaking, if you're more rigorously, there is a way to prove this by showing that x to the third is actually a 1-to-1, and it's also increasing in going from z to z here. And because of that, you can show that there would be no integer solution. Okay, so anyways, hope this helps. And yeah, it's just a kind of an exploration on how defining your domains and codomains differently kind of breaks a lot of the notions that we have about functions that we learned in calculus and algebra. Thank you for your time.